Hello everyone. Uh, Today we are going to be solving this particular problem, which is about a wooden T-beam. Okay, T-beam. This is a T-beam. It's made from two boards. So if the allowable flexural stress is 12 MPa, determine if the beam can safely support the loading shown. So the value that we are going to be getting, which is the or finding, which is the flexural stress, or the actual, must be equal or lesser than 12 MPa to satisfy the question, or if not, then we just simply answer it that the beam cannot safely support the loading. Okay, so it's just simple as that. Now remember that the formula for the flexural stress is just equals to maximum moment multiplied by this centroid and the inertia. That's what I call it. Now in this particular problem, um, which is T-beam, we cannot simply get the center of this by just 200 plus 30 divided by 2. No, we cannot. This is like an unsymmetrical beam, so we cannot just divide the height by 2. So we need to find it. Okay, and also the IXX, we cannot be also get it just by using the basic formula, which is this. No, we cannot get it through that. So moving on, in order to get the value of the C here, we need to make use of this formula, which is just let me put it, change color, which is just area 1 y1, okay, remember this, plus area 2 y2, divide both sides by the sum of area 1 area 2, excuse me. Okay, now for IXX, or the inertia, I think it's called inertia, correct me or correct me if I'm wrong. You need to make use of this formula, which is just basically just base times height cube per 12, but we'll be adding area and the distance. Okay. 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 So this will be a very long uh, process. So hope that you can stay. No. Moving on. Let's draw the this object. Good. Okay. Erase this. Where's the eraser? Get the head out of here, man. I don't need you. Okay. So this is 30 millimeters, and this is 200 millimeters. Okay. This is also 200 millimeters. Bruh. And shocking, this is also 30 millimeters. Okay, so first things first, let's find the center of each shape. So let's call this as area 1 and this by area 2. Okay, so the center for area 2 is going to be here, and the center for area 1 is going to be here. So the distance between here and here is just 200 divided by 2. This is just 100 millimeter. uh, let's also not forget about the baseline, which is this. Let's call it x. Okay, x. Now uh, this thing here, or this distance here, is just basically called y2. So this is y2. Now for y1, okay, y1 is just basically the distance over here, the center of the area 1 towards at the very bottom at the x. So to get the value of this, we just add 200 to 30 divided by 2. So 200 plus 30 divided by 2 is just 215 millimeters. Forgot this millimeters. Okay, so now we got the value of y1 and y2. We can satisfy the conditions for C. Okay, but before that, let's get the value of area 1 and area 2. Now as you can see, both of this shape has the same area, so let's not lengthen the process. Let's just do it fast. So base times height for the formula of area of this shape, if you didn't know basic geometry. So 30 times 200 is just equals to 6,000 millimeters squared, same as to the second area. Okay, let's not delay daddy all night long. So for C, okay. So for C, okay, okay. So area 1 is equals to 6,000 millimeters. Okay, multiplied by y1. Y1 is equals to 215 millimeters. Okay, and then we add area 2, which is again just the same as to area 1 is, and then y2 is 215 millimeters. Okay, and then we divide all of this with area 1 and area 2, so it's just basically 6,000 times 2. Wow, so smart. Let's go. So smart, bro. You're so smart. What the heck, bro? How do you get so smart, bro? I don't know, bro. Oh, what? This is not 215, bro. It's 100. You stupido. Why so smart, bro? Bro. Fucking cringe, man. Sorry. So this is 100. It's supposed to be 100. Okay. I'm sorry about it, bro. Sorry about that, bro. Okay. So now the answer is 157.5 millimeters. So that is the position of our centroid for these two particular objects. So at the very bottom, we start here towards the very up. So let's assume that the centroid is at here. The distance of this is 157.5. Okay. Okay, so this is the C. This is the value of C. Successful. Now we got the value of that. Now let's move on to y-x-x. Okay. So before moving or getting the value of y-x-x, we must get the distance between this and also this. Okay. So let's call this D2 since it is at area 2, and this also as D1, sorry, since it is at area 1. Okay. Now the distance between D between the distance of D2 is just basically what do you call 100 minus 57.5. So D2 is just basically, let me write, D2 is just basically 57.5 millimeters. Oh yeah. Now for D1, it's just 215 millimeter minus 157.5. Oh my god, I might need a calculator for that, bruh, because I'm not a fucking computer, bruh. So the answer for that is just similar, which is 57.5. What? Is it real? Wait. What? Why are they the same? Let me yeah, it's correct. uh I double um make sure of it because I never encountered a problem that has the same distance as to this. Oh, it's fine. I was just shocked. So moving on. So now that we get the D2 and D1, we can satisfy the formula or the components for IXX, or the inertia. Okay, so let's move on. So the formula for IXX is just basically for this is this, but we have two shapes. Okay, so we'll be getting the value this for area 1 and also add it to the value of the area 2. Okay, so the base for the first area, which is this, is 200 millimeters times the height, which is 30 millimeters cubed, divided by 12. And then we add the area of the area 1, which is 6,000 millimeters, multiplied by the distance 1. We'll be using the distance 1 since we are using the area 1. So the distance 1 is equals to 57.5 millimeters. Now after this, we add the second version, which is the area 2 second version. Okay, so the base for area 2 is 30 millimeters multiplied by its height to the power of 3, and then divided by 12 plus 600 6,000, and it's the eastern distance to which is the same. Oh my god. Okay. Now we multiply, add, and then add, and we get the answer. So let me pause the video. So I forgot something, guys. uh, Forgot that the d here in inertia has 2, so it's squared, so this is supposed to be squared. I'm very sorry for that. Now what I want to do is to step by step get the value for each of these. So value for these, and these. So in order to not make any complications, so let's do it. So 200 times 30 to the power of 3, okay, divided by 12. Oh my god, so it's 450,000 plus 6,000 times 57.5 to the power of 2, what, which is 198,375, and we add this value to bottom part, which is 30 times 200 to 200 to the power of 3. Okay, I divided by 12. Is that right? Wait, let me repeat it. Times the power of 3. Okay, so the answer for it is 20 million to 3, right? And then plus 6,000. Oh, it's just the same. 19837 5,000. Now we just add all of this. We get the value, which is let me 19837 500 times 2 plus 4. Okay, so the correct value answer is 125. Okay, so this was supposed to be the value. Okay, so this is our IXX. Now if you ask what is its unit, so basically it's just millimeter to the power of 4 since this problem uh, is about kilonewtons, so it's just millimeter to the power of 4. Oh my god. Putang ina. Bro.